Welcome to another MCAT JEE session, prep session. So here is I promise that I'm going to go into a circular motion now. But before I go, I recall thinking about doing this problem for you guys. So this is actually a good problem. Here is a ramp, and there's a cannon here. So this is this projectile you're going to send, and and you're going to shoot it at speed v0 at angle phi with a ramp. And the question is where on the ramp is going to hit. So this is considered as a hard problem. So if you want to make it a little easy, you could say, let's change this problem to an easy, and then later on do a hard problem, okay? So let's call this guy a 30 degrees, and let's call that 30 degrees, and this is what we need to find. And let's call this 40 meter per second, and assume ramp goes forever, okay? So ramp is long enough, maybe it's the hill or whatever, side of a hill is long enough that this is going to land on that, okay? A ramp or hill side. All right. So with this simplification, a lot of numerical values will be worked out very nicely. So here you can see that at all these points, acceleration is pointed down, right? That's acceleration is pointed down. Then how I'm going to make sure that I have simple enough equations. So one of the axes will have to be in that direction. So we just pick y-axis in that direction, and we can put x-axis in that direction. And this will actually simplify because on acceleration will be in the y component just before. So so here, so acceleration is I'm going to just do xy plane motion, so don't have to worry about the z-axis and writing like that. So this would be 0 minus g. v0 vector is pointed that way, and with respect to x-axis it is this angle. So let's call it theta with respect to x-axis is theta plus phi, which is 60 degrees. So I'm going to have a v0 cosine 60 degrees, and this will be v0 sine 60 degrees. So that's going to turn out to be 40, or this is going to be 20, and it's going to be 20 square root of 3, because this is equal to half and this is equal to square root 3 over 2. So that's going to be like that. It's going to come out here, hit at some angle. I'm just going to call this v vector, and I don't know is x component, y component, so I just leave it like that. The r vector at 0 is just 0, 0, and r vector over here is what we want is d. So it's just d. So r vector, its x is some value x here and some value y here. So just leave it x and y. This is all simple notation. So we just need to do x equation and then y equation. The x equation will be this will have to be that because acceleration is 0. So this is Vx is simply V0x, which is 20 meter per second. No acceleration, right? You understood that. And x coordinate, change the x coordinate to this x0. That's just going to be V0xt. But this is not known. So that just gives me x equal to 20t. So let's call this one equation. I have two unknowns. I need to figure out t to figure out x. If I know x, so you can see the d, if I knew x, d will be so x over d will be cosine theta. So the d will be x over cosine theta. So that's so if I knew x, then I could get d, but to know x I need t, and that's where the y motion will help us. So let's look at in the y motion we are where Vy is going to be V0y acceleration is minus g t. So this is 20 square root of 3 minus 10 t. So I'm going to say ug equals to 10 meter per second square. This is okay, just for brevity. So here I don't know this and I don't know this, and then you have a y equal to v0y t, y minus 0, the change in y. This is 0, so that's that guy. v0yt plus half minus g t square. So y just turns out to be v0y, which is 20 square root of 3 t minus 5 t square. So here again we don't know y and we don't know t. We don't know t. So, but really, fortunately, we don't need to know the t. So we're kind of stuck. We don't have any information, do we? Can you think about, so there's some information that we also have it here. So here it says hits on the ramp. So you can write the equation of the ramp. On ramp, you can see y, any coordinate, if this is y and this is x and this point is on the ramp, so the y over x is tangent 30 degrees. So that's, so this is equation number 3. So what we can do is use this for t in terms of x and plug these guys, and we can plug this guy in terms of x, so that these pluggings will give, this will give one equation in x. All right, so let's do that out. So for y, I'm going to have, and so this just means y equals to x over square root of 3, and then 20 square root of 3 and this just means t equals to x over 20. So this is x over 20. So this 20 cancels out. Minus 5 x over 20 square. So this is all x. So let's see, bring everything on one side. So this is 5 over 400 x square minus x square root 3 plus x over square root of 3 equal to 0. And we can take x common now. I hope I'm not making any numerical mistakes. So x common now, 1 over 80x minus square root of 3 plus 1 over square root of 3 equal to 0. So this means either x equal to 0 or 1 over 80x minus 1 over square root of 3 minus square root of 3 plus 1 over square root of 3 equal to 0. So now this value is corresponding to this point. So we don't want that point. We want another point, and that's the other point. So we want this. Both are mathematically okay, but this is our physical solution. So the answer from here should give us x equals to a square root of 3 minus 1 over square root of 3, this whole thing times 80, right? Well, we can simplify a little bit. So 80 over square root of 3 times 3 minus 1 is 160 over square root of 3, or 160 over 3 is square root of 3. Normally you put the square roots in the numerator, okay, if possible. So that's the x. And so we go back to our question for D. So D is equals to x over cosine theta, and this is 30 degrees, x over cosine 30 degrees, and this is equals to half, so this is 2x. So it just tells us that this will be 320 over 3 square root of 3 meters. That's the answer. So this is a pretty instructive problem. Is I went through stages of solving, writing all these vectors first, and t is not a vector. I left out t here. So these are the known and unknown quantities here, all list of all of them. And then when you go down here, you can generate equation A, equation B, equation C, and equation D. That's 4 equations. That's all you can generate. But if you look at the unknowns, I could have already known that there is some problem. Okay, this is completely known. This is completely known. So there are these 2 unknowns, and 3, 4, and there are 5 unknowns, and only have 4 equations. So I would have known that I'm missing something that should be there. And sure enough, looking at this, we put down over here, we're missing this one. So after analyzing, we said, oh yeah, this is all required to be hit on the ramp. So when you list this down, and there has to be, it can all, if there are no other conditions, then it can't be more than 4. Okay, you can't solve it. So if you find more than 4, then you should look around in the problem if there is some other condition that you're missing. That's why I wanted to do this problem for you. That there are conditions sometimes in the description that you have to look for. All right, that would be it for today. For this problem, I will try to put. Now I'm going to move on and put circular motion. I think that's another common motion that shows up in a whole bunch of situations, both physical situations in real life and uh, in problem settings. They're kind of not so difficult to handle as long as you know some of the basics. Okay, take care. Bye.